Welcome to this ADCR presentation on how to execute at a site to ensure compliance with the obligations set out in the granted ADCR authorizations and their corresponding implementing decisions for the EU REACH authorizations. My name is Anne Bierwisch from Phobic and I am your host for this presentation. As part of the ADCR post-decision activities, flowcharts have been prepared to help you identify which actions you must take to ensure compliance. The flowcharts can be found on the ADCR website under Granted ADCR Authorisations. If you would like to familiarize yourself with the obligations of the implementing decisions before using the flowcharts, please watch the presentation Overview of Obligations provided on the ADCR website under Webinar Series. In this presentation, I will go through the guidance flowcharts for ensuring compliance with required conditions, and afterwards we move on to the guidance flowcharts for determining if feasibility studies are required. I will start with the guidance flowcharts for ensuring compliance with required conditions. Whilst every care has been taken in the preparation of these flowcharts, please note that errors may still be possible. These flowcharts are for your guidance and do not constitute legal advice. All legal obligations are set out in the implementing decisions, which are the legal documents to be consulted. ADCR is not liable for any omissions or misunderstandings or for the results obtained from the use of information presented in this presentation. The information is intended for guidance only and is to be relied upon at the user's own risk. No representations or warranties are made with regards to its completeness or accuracy, and no liability will be accepted by ADCR or its members for damages of any nature whatsoever resulting from the use or reliance on the information. In total, 5 guidance flowcharts to ensure compliance with required conditions are available, which cover all the 11 uses the ADCR consortium applied and received granted authorizations for in the European Economic Area. All of the ADCR authorizations have received similar obligations with minor deviations for some specific uses. The first flowchart covers 6 surface treatment uses with identical obligations. The second, as well as the fourth and the fifth flowchart, are for the uses of anodizing, passivation of non-aluminium metallic coatings, and slurry coating, which differ in a few obligations from flowchart 1. Flowchart 3 is for formulators, formulating chromated products. I will in the following present 2 flowcharts exemplarily. Flowchart 1 informs about the necessary action and obligations downstream users have to fulfill when performing anodized sealing, chemical conversion coating, electroplating, inorganic finish stripping, pre-treatments or passivation of stainless steel with chromates granted under the ADCR authorizations. For the granted use of hexavalent chromium, downstream users must ensure that they fulfill the actions 1 to 6, among other actions presented in the flowcharts. As you are familiar with the REACH regulation and the authorizations, these actions are not new to you. We present them here as an overview and a way to help you fulfill all requirements. Please note that all these measures and topics addressed in the flowcharts are typically common knowledge for the persons responsible for environmental health and safety at your site. Under Action 1, the Risk Management Measures RMMs and Operational Conditions OCs of each task are reviewed and ensure that the use is in accordance with the relevant exposure scenario described in the Safety Data Sheet, SDS, of the chromated product. Please see the product SDS or ADCR website for further information. As you are aware, under an authorization in the European Union, you as a downstream user ensure that occupational exposure to hexavalent chromium is at a level as low as technically and practically possible by implementing conditions that follow the hierarchy of control principles set out in the Article 5 of Directive 2004/37 of the European Commission, the so-called Carcinogens, Mutagens, or Reprotoxic Substances Directive, CMRD. This is Action 2. As a reminder, the hierarchy of control principles are also provided in the flowchart 6 and will be shown at a later stage in this presentation. Action 3 reminds you that you have to notify to the European Chemicals Agency, ECHA, via REACH Article 66, which authorized uses are performed at your site and with what chromates they are carried out at your site. Regular monitoring programs for occupational exposure and environmental releases to air and wastewater, which were already a part of the obligations under the initial authorizations, also have to be carried out for the ADCR authorizations, as mentioned under Action 4. If you have previously conducted biomonitoring program at your site, you have to continue with the measurements. The next action highlights that you, as a downstream user, have to assess whether feasibility studies for the authorized hexavalent chromium use need to be performed. Feasibility flowcharts are provided to assist in the decision-making process. These will be explained in detail later in this presentation. Action 6 deals with the substitution of chromates, which is a key part of authorizations. You must document a substitution plan, record any deviations or challenges faced, and make this information available to the competent authority on request. Further action is required from you, for example, the request in the implementing decisions to install technical improvements. The flowchart will help you to identify the actions you need to take. From here, you get to a decision tree. Please note that although the questions in the decision trees are presented in order, each measure shown in a diamond shape needs to be targeted individually. This applies to all presented flowcharts. We start at question 1, which consists of 2 parts. The first part asks, is each use of hexavalent chromium controlled to ensure that exposure is as low as technically and practically feasible? And the second part of question 1, from the monitoring results you have gathered, can you conclude that the hexavalent chromium exposure is as low as technically and practically possible? If you answer both questions with yes, then no further action is required and you can move on to question 2. If one or both questions are answered with no, you must start with action 7. For most of you, this will not be new. Under the European REACH authorization regulation, you must comply with the hierarchy of control principles set out in Article 5 of the CMRD. This means you have to implement the necessary technical improvements to the RMMs and OCs to ensure that the occupational exposure to hexavalent chromium is as low as technically and practically possible. For installing the technical improvements, a use-specific deadline of either 28 October 2025 or 20 January 2026 is given in Table 1. As said before, the hierarchy of control principles will also be explained in detail later in this presentation. After you have installed the technical improvements, you need to carry out control measurements to verify that the occupational exposures to hexavalent chromium are as low as technically and practically possible. Please note that this process may be iterative and you may need to implement various technical improvements or measures until you can conclude that the exposure is sufficiently low. As a deadline of either 28 October 2025 or 20 January 2026 is given, it is important that you are aware of all the actions given in all questions of this flowchart and corresponding flowcharts, for example the hierarchy of control flowchart or guidance flowcharts for feasibility studies. If you begin with Action 7, you must at the same time start with Action 8, which requires that while Action 7 is ongoing, workers need to wear respiratory protective equipment, RPE. In the implementing decisions, it is specified that for manually performed tasks, for example for the immersion of articles in the treatment bath, bath sampling and bath makeup, RPE is worn while the installation of technical improvements is not finalized. Please note that some manually performed tasks are use-specific, which is indicated by special characters. So for example, filling of parts applies to chemical conversion coating, and touch-up activities apply to passivation of stainless steel and chemical conversion coating. As a downstream user, you must ensure that workers are provided with adequate RPE that has been fit tested prior to the first use, and the workers are supported in performing the fit test. In addition, the workers must perform a fit check of seal before starting a relevant task and be trained in undertaking the fit check. Further information on both fit tests as well as guidance on appropriate RPE can be found under the link provided in the flowchart. In the ADCR presentation Overview of Obligations and the guidance document on the presentations and obligations from the implementing decisions, which will be published in March on the ADCR website. Then we move on to question 2. In the implementing decisions of the hexavalent chromium authorisations, it is an obligation that manual measuring, weighing and solution preparation of solid and liquid hexavalent chromates is performed under local exhaust ventilation, LEV, with high containment. We provide an interpretation guide on what can be regarded as high containment in the ADCR presentation Overview of Obligations. Additional information on LEV systems can be found in a guidance document on LEV published on the EU OSHA website. A link to this document is provided in the flowchart. If you can answer yes to question 2, then you do not need to take any further action for this requirement and can continue with the regular monitoring programs. If a LEV with a high level of containment is not available for the manual task, you will need to carry out Action 9 and implement a LEV with a high level of containment. Afterwards, you have to verify that the exposure to hexavalent chromium is as low as technically and practically possible by performing measurements. If you can conclude from the monitoring results that the exposure hexavalent chromate is as low as technically and practically possible, no further action has to be done. In case your conclusion disagrees with the question, please check if you are in accordance with all measures given in Article 5 of the CMRD and where necessary adapt or implement technical improvements. Afterwards, you have to verify by measurements that you can conclude that the exposure to hexavalent chromium is as low as technically and practically possible. This was one example how the flowchart can guide you to ensure compliance with the obligations given in the implementing decisions for each use. Please note to also review the corresponding flowcharts on hierarchy of control principles and feasibility studies. As presented in the introduction, anodizing, passivation of non-aluminium metallic coatings, and slurry coating differ in a few obligations from the ones given in Flowchart 1. Flowchart 2 is for the use of anodizing. The actions 1 to 6 are identical to Flowchart 1 and were explained in detail previously. 1. When starting the decision tree, question 1, which asks if hexavalent chromium exposure is as low as technically and practically possible, and question number 2, which addresses if manual tasks with solid and liquid hexavalent chromates are performed under LEV with high containment, as well as their corresponding actions, action 7, 8, and 9, need to be addressed as explained in detail in Flowchart 1. For anodizing, a use-specific obligation is addressed in question 3. This asks if selective anodizing is performed in dedicated rooms under LEV. If your answer is yes, then you do not need to take any further action and can proceed to question number 4. If your answer is no, and you carry out selective anodizing at your site, ensure that it is from now on carried out in a dedicated room under LEV. Please see Article 2, Paragraph 2c of the implementing decision. Verify throughout control measurements that the exposure to hexavalent chromium is as low as technically and practically possible. If the exposure to hexavalent chromium is not as low as technically and practically possible, further measures shall be taken until this is achieved. Then proceed to question number 4. Question 4 is asking if mechanical ventilation is used for machining activities in on-site small work areas. If this is the case at your site, you do not need to take any further action for this requirement and can continue with the regular monitoring programs. In case you reply with no, a follow-up question asks whether mechanical ventilation would introduce a risk. Again, if you answer with yes, you do not need to take any further action and proceed with the regular monitoring programs. In case you disagree, take action 11 and implement mechanical ventilation for carrying out machining activities in on-site small work areas. Verify throughout control measurements that the exposure to hexavalent chromium is as low as technically and practically possible. If the exposure to hexavalent chromium is not as low as technically and practically possible, further measures shall be taken until this is achieved. This was an example for a flowchart with use-specific obligations. In this flowchart document, you find additional flowcharts with use-specific requirements for formulation, passivation of non-aluminium metallic coatings, or slurry coating. Now I will present flowchart 6, which provides an overview of the hierarchy of control principles given in Article 5 of the Directive 2004/37 from the European Commission. the so-called carcinogens, mutagens, or reprotoxic substances directive, CMRD. A link to the directive is provided in this flowchart. The hierarchy of control principles is designed to prevent and reduce the exposure of workers to carcinogens, mutagens, or reprotoxic substances at work by means of replacement, substitution, technical, organizational, and personnel measures. The implementing decisions refer to Article 5 of the CMRD to reduce the exposure to hexavalent chromium substances. The first question asks if an alternative for the hexavalent chromium substances is available that can be used. When you have a suitable alternative that is qualified and available to be implemented for use, then you need to take the following actions. First, implement alternatives for all users' tasks where possible. Second, update the Article 66 notifications sent to ECHA if all users under any authorization number have ceased. And third, for the remaining hexavalent chromium substances that cannot be substituted yet, ensure you are compliant and meet all the requirements given in the granted authorization. You can use the flowcharts for the implementing decisions as guidance. If there is no alternative, you must also ensure that you comply with all the requirements set out in the granted authorization and proceed to the second question. The second question asks whether the quantities of hexavalent chromium substances used are kept to a minimum. If this is not the case, you need to take action to reduce the amounts of hexavalent chromium substances to a minimum for all uses taking place. No action is required if the quantity is already at a minimum. However, irrespective of your use quantities, you proceed to the next question, which is, are the numbers of workers exposed to hexavalent chromium kept to a minimum? If this is not the case, you need to put measures in place to reduce the number of workers exposed to hexavalent chromium to a minimum. No action is required if the number of workers is already at a minimum. Both possible answers to the last question lead to the next step, where you need to verify control of exposure and releases by means of monitoring. You use the monitoring data collected to assess whether the processes and engineering controls in place minimize the releases of hexavalent chromium to levels as low as technically and practically possible. If you can answer yes to this question, you should repeat the monitoring of exposures and releases annually to verify that the controls and conditions continue to be effective. In addition, you should document the monitoring data and make it available on request. If your answer is no, you have to review the processes and controls and implement improvements to reduce hexavalent chromium exposures and releases. A non-exhaustive list of measures to be taken where technically and practically possible is shown in the flowchart. For example, ensure good hygiene measures and workplace cleaning takes place for all tasks using hexavalent chromium. After implementing the improvements, you need to verify again the control of exposures and releases by conducting monitoring data and verify if processes and engineering controls are in place to minimize hexavalent chromium releases to levels as low as technically and practically possible. This can be an iterative process until you reach the conclusion that hexavalent chromium releases are minimized to a level as low as technically and practically possible. From that point following an annual routine for monitoring of exposures and releases to verify the controls and conditions continue to be effective. This was the flowchart on hierarchy of controls. In the last part of this presentation, I will present to you the guidance flowcharts for determining if feasibility studies are required for the use of chromates in accordance with the EU REACH ADCR authorization decisions. The flowcharts can be found on the ADCR website under Granted ADCR Authorisations. This guidance flowcharts document contains in total 4 flowcharts which were developed for the 11 ADCR users. The first flowchart covers 7 users, which have the same measures to address in a feasibility study in common. The remaining flowcharts are use-specific. Flowchart 2 is for electroplating and chromate rinsing after phosphating, flowchart 3 for formulation of mixtures, and flowchart 4 for slurry coating. In the following, I will present to you flowchart 1 exemplarily. Flowchart 1 will help you determine if you have to conduct a feasibility study for the ADCR uses of anodizing, anodized sealing, chemical conversion coating, inorganic finish stripping, passivation of non-aluminium metallic coatings, passivation of stainless steel, and pretreatments. The first measure that is addressed in the decision tree is the use of solid chromates for any task. If your site does not use any solid chromates, no further action is required and you can proceed to measure 2. If solid chromates are used, the second question is whether solid chromates are exclusively used in a closed or automatic system for dissolution and subsequent bath refilling. If this is the case at your site, no action is required and you can move forward to measure 2. In case the answer is no, then you need to take an action. This means that you must carry out a study to determine whether it is feasible to substitute solid chromates with liquids or to implement a closed or automatic system for the dissolution of solids and any subsequent refilling of the bath with liquid solutions. For finalizing the feasibility study, a use-specific deadline of either 28 October 2025 or 20 January 2026 is given in Table 1. Afterwards, we proceed to measure 2. If bath sampling is performed using a closed or automatic system, then no further action needs to be taken on this measure. If this is not the case, you should assess whether hexavalent chromium exposure is expected during sampling. If no exposure is to be expected, you can move forward to measure 3. If exposure is expected, you must carry out a feasibility study in which you elaborate if it is feasible to install a closed or automatic system to perform bath sampling tasks and go to the next measure. The next measure leads to the question, is a continuously controlled LEV system with automatic alarm in case of malfunction in place? In case your answer is yes, you can proceed to measure 4. If your answer is no, further action is required from you. In a study, you must investigate if it is feasible to install a system that continuously controls the LEV and automatically triggers an alarm if the LEV is not functioning properly, and the implementation of appropriate and effective measures to reduce the exposure of workers in case the LEV is not functioning properly. Then we move on to the last requirement, which is to have an air abatement system in place for hexavalent chromium task. You can proceed to the next step if your answer is yes. If you answer with no, a study elaborating if it is feasible to install an air abatement system has to be carried out. Please note it is a requirement even if exposures to hexavalent chromium are expected to be low. The next step serves as a control for you to conclude if any feasibility study is necessary. So while going through the flowchart, you may have come to the conclusion that no feasibility study is required. If this is the case, it can be concluded that you do not need to mandate feasibility studies. If you conclude that feasibility studies are required, please proceed with the feasibility studies and complete them no later than the use-specific deadline of either 28 October 2025 or 20 January 2026 as given in Table 1. The form and scope of a feasibility study are not defined in the implementing decisions. In the presentation overview of obligations available on the ADCR website under Webinar Series, we outline a few considerations that could be reasonably addressed in a feasibility study. Then we come to the last step of the flowchart, which asks if you conclude that it is feasible to implement any of the measures. If your answer is no, please document and retain the feasibility studies and their conclusions. If you conclude yes, you must implement the measures identified in the feasibility studies. I have now completed the review of one example of a guidance flowchart for determining if feasibility studies are required. I hope that this presentation was useful and that it helps you to ensure compliance with the obligations set out in the granted ADCR authorizations. Thank you for your attention and have a good day.